My cell's gone work, I'm wondering how they make ATP. The different cycles work together, so we have energy, glycolysis and Krebs and OP. They're the big three. They remind me that I'm working hard.
Dear glycolysis, I wrote you, but you still ain't calling. I left my C, my H, and my O in the glucose column. I sent 2 ATP back in step 1, you must have got 'em. You might have broken it up into G3P or something. By the way, I make 2 NADH when I'm working. But anyways, frick it, what is up, man? How's your ADP? My ADP's pregnant too, she's about to get a phosphate. If I have an ATP, guess what I'ma call her? Adenosine triphosphate. I read about your 2-net ATP, I'm happy. I had some energy doing work, made it snappy. I know you probably hear this every day, the latest craze. I even got the energy investment, that's the first phase. I got the energy payout phase 2, that's the second. I like the stuff you did in the cytosol too, that thing was fat. Anyways, sublevel phosphorylation gave ATP back just to chat. Truly yours, your biggest dude. This is Jude.
My cell's gone work, I'm wondering how they make ATP. The different cycles work together, so we have energy, glycolysis and Krebs and OP. They're the big three. They remind me that I'm working hard.
Dear Parody, you're on your way to the Matrix, you're making that H. I ain't mad, but why'd you get rid of CO2 in that stage? If you just wanted to be acetyl-CoA, dude, I get you, I understand. I know you had to, but why'd y'all have to disband? That broke the little heart, man. Added coenzyme A, he waited in the blistering cold for you, gave you oxygen just in hopes you stay. That's pretty stupid, man, you just turned it into carbons. You added coenzyme A, man, I know you got your reasons. I ain't mad though, I just know you're moving in Krebs. Sincerely yours, Parker, P.S. You're my favorite celebs, Krebs.
Cell's gone work, I'm wondering how they make ATP. The different cycles work together, so we have energy, glycolysis and Krebs and OP. They're the big three. They remind me that I'm working hard.
Dear Mr. I only make 2 ATP and 6 NADH. It's me again. Acetyl-CoA, now I'm joining oxaloacetate. Citric acid cycle, what a crazy twist. I'm getting NADH, FADH2, you get the gist. From citrate to 5 carbons, yeah, I'm turning in style. I'm spinning that cycle for a little while. I produce more ATP, I can feel the rush. 2 more spins, I'm ready for the next big push. 4 carbons is where it ends, regenerate back to the start. I hope you're listening, I hope it hits your heart. Now that's kinda where it is. Step 1 makes citrate, now it's too late. I already released CoA, don't hate. All I wanted was NADH in step 2, that's what was CoA's fate. I hope you know step 3 makes another NADH after losing a CO2. Now we down to 4 carbons, I missed the other 2. I ruined it now, it's not a citrate, but don't be upset. It regenerates back to oxaloacetate, give it a sec. Let that set, 1 ATP, 3 NADH, 1 FADH2, all the net. Do the cycle twice, you gotta double it. Hey Krebs, that's my part of CR, finished to my best. I still haven't made much ATP, you gotta wait for the rest. I know this so well, I might be ready for my test. Well, gotta go, I'm almost ready for OP. I have to send my carriers down to the ETC.
My cell's gone work, I'm wondering how they make ATP. The different cycles work together, so we have energy, glycolysis and Krebs and OP. They're the big three. They remind me that I'm working hard.
Dear Mido, I meant to write you sooner, but I've been busy. I was shuttling electrons to the ETC, now my proton gradient's feeling dizzy. You said you're in the inner membrane, how far along is the process? Look, I'm really flattered that you pump protons with such finesse. And here's some NADH, I wrote it in a glyco rap. I'm sorry I didn't see you last cycle, I must have missed that gap. But what's this about the proton gradient? Is it ready to go? Why does it feel like taking forever to get the flow? You got some issues, Mido, I think you need some regulating. You're pumping protons out, but the gradient's still fluctuating. And what's this about oxygen being the final acceptor? Without it, man, you'd be stuck. How would you be the energy director? If you just relax a little, the proton pumps will be fine. I know you're working hard, but mitochondria don't cross the line. You're supposed to spin ATP synthase, that's the key. But why's the proton flow so slow? Can you just work with me? I've been thinking. NADH, FADH2 are here to donate. Electrons passing through the chain, making the gradient great. They give up electrons, which move down the line, creating a gradient as protons start to climb. The gradient builds, it's pushing protons across, into the membrane space, it's a high energy toss. Now protons rush back to ATP synthase, spinning the rotor so ATP can be made.